Okay, so welcome back to my channel. You can see a slide in here that says organic and inorganic molecules. So yeah, we're going to be studying about the difference between organic and inorganic molecules today. And we're going to be doing another topic with this. So let's move on. First of all, ask yourself a question. Do you know about the organic molecules? And do you know about the inorganic molecules? You've probably heard about this term in your chemistry classes. The organic molecules are basically those molecules that are like the carbon, hydrogen, they're, that are basically the derivatives of hydrocarbons. So, and the inorganic molecules are basically those molecules that are other than the hydrocarbon derivatives. Like Yeah, so let's just move on to the basic point. So what's the difference between these two? Organic molecules usually do not dissolve in water, but there are some organic molecules that do dissolve in water. Like there's alcohol, and the inorganic molecules usually dissolve in water. Like you can see the salt, but there are exceptions to this too. Like there are some inorganic compounds that do not like to dissolve in water, and then the organic compounds generally dissolve in organic solvents like ether, alcohol, benzene, and chloroform, while the inorganic compounds generally do not dissolve in organic solvents. Organic compounds have usually low melting points and boiling points, and they usually decompose in heating, while the inorganic compounds usually have a high melting point and boiling point and usually do not decompose in heating. This can differ because you can see the the bicarbonate, the carbonates, they do decompose in heating, and they are inorganic compounds, right? So the organic compounds are inflammable. They catch fire easily. Like you can see the alcohol is highly inflammable. And the inorganic compounds are usually non-inflammable. Like they do not burn easily. The last difference I can see in here says organic compounds exist as covalent molecules. So they are non-electrolytes. Of course, there are exceptions that there are some organic molecules that can carry the current, and the inorganic compounds mostly the inorganic compounds are ionic, so they are electrolytes. I'm not saying that those are not covalent, but yeah, it basically just depends on the polarity. We'll be discussing more about that in the chemistry series, so stay tuned for that. Okay, next step, we've got the difference between the covalent, ionic, and hydrogen bond. So what's a covalent bond? The covalent bond is a chemical bond formed by sharing of electrons between atoms. This type of bond occurs when two atoms have similar electronegativity, which means they have similar abilities to attract electrons. Covalent bonds are generally stronger than other types of bonds and are commonly found in organic molecules. So covalent bond, I'll give you an example. Water. It's a covalent bond, right? And you can see alcohol. You can see benzene, and these are covalent and are organic, right? Benzene and alcohol. Other than that, you can see the oxygen molecule. That's a covalent bond, right? That has a covalent bond between them. The both the oxygen molecules are basically sharing the electrons. Okay, let me draw this. This is an oxygen molecule. I'm just drawing the valence shell. Okay, let me just change the color to Wait a second. Yeah. So these are we've got 6 electrons in the outermost shell of oxygen. 1, 2, 3, 4, 5, and there's 6. Now draw another one. Just a second. Yeah. So this is another oxygen molecule. Now draw the electrons in the cross, not the dot. 1, 2, 3, 4, 5, 6. So these are, you can see this right here, right? These are two different molecules, but when they do a bonding thing, they're basically sharing two of these electrons from one another. Like you can see, I'll just draw it. Wait a second. Okay, so here you can see an oxygen molecule. You can see the green electrons. Those are the atom number 2 of oxygen, and the first one is has a yellow electrons. So basically, this is overlapping. They're making an S bond. Okay, so their SS shells are overlapping. We'll discuss this in further detail when we're studying chemistry. So let's move on to the other things. Okay, so ionic bond. We've got the ionic bond next. So ionic bond is the electrostatic attraction between the opposite charged ions. In an ionic bond, one atom loses an electron and becomes positively charged, while the other atom gains electrons and becomes negatively charged ion. The positively and the negatively charged ions then attract each other, forming an ionic bond. The ionic bonds are generally weaker than the covalent bonds. Okay, now just to give you an example, I'm going to be drawing sodium and chlorine because that's an easy example. Sodium has just 1 electron in its outermost shell, while chlorine has 7 electrons in this outermost shell. Let me draw the electrons, just a second. It's really troublesome to draw this thing. Okay. 1, 2, 3, 4, 5, 6, and then 7 electrons. So sodium would completely just give up its electron to chlorine, and then it will look like this. Like sodium will become positive. It will become positive, and the chlorine atom, which will have sodium's electron, its own electrons, will become negatively charged because it has 1 extra electron from the sodium. I wouldn't call it extra, it's just a bonding electron maybe. So it gets a negative charge. That's how basically the covalent bonds are formed. Okay. Let's move on to the next slide. Got the ionic bond, the covalent bond, and then we've got the hydrogen bond. So let me just erase everything. Okay, so hydrogen bond is a type of intermolecular bond that occurs between a hydrogen atom bonded to a strongly electronegative atom, such as oxygen or nitrogen, and another nearby electronegative atom. This bond is relatively weak compared to covalent and ionic bonds, but it can have a significant effect on the properties of molecules such as high boiling point of water due to the many hydrogen bonds between the water molecules. So alcohol, it's got hydrogen in it, so it'll make a hydrogen bond. Water is it's got so much surface tension because of hydrogen bonds. Yeah, so that's how hydrogen bonds basically work. And that's all for today. Thank you so much for listening to me, and bye bye.